Hey, Science 10 people. So, here we are again. This is your very last chemistry lesson, so I know you're probably pretty excited about that. So today we're going to talk about organic compounds. So your level of understanding that you kind of need to have for grade 10 science isn't super in-depth. In Chem 11, if you choose to take it, it does get much more in-depth. I think it's Chem 11. It might be Chem 12, but either one. For you, you just kind of have to be able to look at something and figure out whether it's organic or not, and maybe identify a compound based on its model or something like that. So I'll kind of take you through it as quickly as I can. So organic compounds are all about carbon. Carbon is kind of the magic ingredient in organic compounds, and it's a good thing that carbon acts the way it does, otherwise there'd be no life on Earth. So every living thing on Earth is, well, I shouldn't say every, most living things on Earth are carbon based, and that includes us. And the reason that organic compounds are so special is that because carbon, with its 4 bonding sites, 1, 2, 3, 4, this is a Lewis dot model, we know it's in column 14, it has 4 electrons in its outer shell, which gives it 4 bonding sites to form covalent compounds. And the really cool thing about carbon is that it can bond with itself over and over and over again. So you can get these carbon compounds in like big long chains, or they can be in rings, or there's all sorts of variety that you can have with carbon-based molecules. So all organic compounds contain carbon. That's really important, and it will help you when you have to identify something as being organic or inorganic. Not all carbon-containing molecules are organic, but all organic molecules do contain carbon. They usually contain hydrogen, so if you see carbon and hydrogen in combination, that's a pretty good indicator that you're going to have an organic compound. So look for hydrogen. There are 3 ways that we represent organic compounds using models, kind of like drawings. You've probably seen me in class draw things, you know I'm horrific, but I'm going to try to do this. So CH4, that's the simplest hydrocarbon in existence. It's methane, more crudely known as cow farts. Yeah, I know, I'm sorry. So we can take any of our organic compounds and we can represent them in a few different ways. So the first way to represent them is the structural formula. So in the structural formula, we just have carbon, and we have straight 2-dimensional lines forming around carbon, and then we have hydrogen attached there. So it's like a Lewis dot drawing. Remember back in the covalent compounds we drew Lewis dot models? That's basically what the structural model is. The other 2 are a little more graphic, so you don't get the letters. So you kind of have to interpret what they look like based on these drawings. So carbon is, throughout this lesson, is going to be identified as this like white, imagine it as being a sphere, not a 2-dimensional circle. I just can't draw that well. And again, we're getting like that. And then hydrogen, because it's smaller than carbon, it's going to be a smaller sphere. Okay? So in this case, our carbon is our large white circle, and the hydrogen are the small gray circles, and then the bonds are just the little black lines. Okay, and then the space filling is even more 3-dimensional. So instead of showing kind of the balls and the sticks, yeah, I know, it's ball and stick, giggle now, get over it later, we show more kind of globular spheres. So in this one, I'm just going to get my pen size up a little bit. We've got our carbon, and again, we're imagining kind of like a 3D sphere type thing. And then hydrogen, it kind of like, I don't know, imagine that's kind of like a sphere that you can't really see in behind it. So it's just like all of these little spheres attached to it. So again, the carbon is the big white one, and the hydrogen are these little smaller gray spheres. You can't see the whole sphere. It is a sphere, but you can't see it because of the big carbon atom in the way. So those are the three models: structural, ball and stick, and space filling. Yeah, so that's pretty much it for that. So I'm going to give you a sample question, so how that kind of comes, like how you might be asked questions. And again, all of your exam questions are going to be multiple choice questions. So first of all, looking at this one, and you're asked, what model is this? So all you would have to do is compare it to the models that you already know. Which one does it look like? Well, of course it looks like the ball and stick. So this is a ball and stick. So that's your answer to number 1. For number 2, we have to get a little bit more savvy here. So for the chemical formula, remember our chemical formulas are when we use the atoms and the subscripts. So in this one, for the chemical formula, I have 1, 2, 3, 4 carbon atoms. So I'm going to write C4, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So this is a hydrocarbon, C4H10, okay, also known as butane. You don't have to know how to name these things in Science 10. You will have to know how to name them next year, or whichever one it is. It gets a little complicated, but you'll be able to figure it out. Don't worry. So yeah, that's just a sample question with the models that you might have to look. So you have to look at this and know that that's carbon and that's hydrogen, and each one of them represent a different atom, and then turn it into something like that. Okay. Last little bit here. There are a lot of different types of organic compounds. Not just these two, but the two that you have to be aware of for this course are hydrocarbons and alcohols, and they're really easy to tell apart. Hydrocarbons only contain carbon and hydrogen. So this is example 1 here, this is example 2 here. So in example 1, I've got 3 carbons, and I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Okay, only carbon and hydrogen. This is what we call a condensed structural formula. Or a condensed chemical formula, one of the two. I think it's condensed structural formula. So this is a chemical formula. If I were to write the chemical formula for this, it would be C4H3,5H10. So the chemical formula for this one is the same as this one up here. So it's C4H10, but we can also be a little bit more specific, and this just shows how it bonds. So if I were to draw it, okay, we've got H's at the end of each of these lines. And I don't know, sometimes with this drawing program, these short little lines are hard to draw. Alright, so if you look at this formula right here, this CH3, you look at this, belongs to this CH3 here. Okay, so you can see CH123. This CH2 is this CH2, so you've got CH2. This CH2 here is this one right here, and this CH3 is this CH3 here. So it's just another way to represent it, and some of the questions, basically you'll just get something like that, and you'll have to say, hey, is that a hydrocarbon or an alcohol? And you'll be like, well, there's only carbon and hydrogen, so it's a hydrocarbon. The last one, the alcohols, the biggest difference is they contain oxygen. So they look like hydrocarbons, but then they have an OH kind of tacked onto them somewhere, thrown in there. So the formula for this one might look like this: C3H1, 2, 3, 4, 5, 6, 7, 8, H8O. Sometimes you might get it written as C3H7OH. Okay, so anytime you see an O in your structural formula, you know it can't be a hydrocarbon because it only contains carbon and hydrogen, so it has to be an alcohol. Alright, that's pretty much it for organics. We're going to talk about this in class on Friday, so make sure you watch. Well, I guess if you've gotten to this point, you've already watched it, so I'll just stop that little thought there. Hope you have a good night, and tomorrow, well, I'll see you tomorrow. Bye.